When Tesla quietly released a video showing the Tesla Semi charging at 1.2 megawatts, the internet did what it always does, reacted in shock. 1.2 megawatts. For most people, that number doesn't even sound real. Today's fastest passenger EV chargers peak around 250 to 350 kilowatts. What Tesla just demonstrated is nearly 5 times higher. At first glance, it feels like another Elon Musk headline moment, another viral clip, another wow number. But once the excitement settles, a much more serious question appears. Is this actually practical or just impressive? Welcome back to InfoByte Network. Today, we're breaking down what 1.2 megawatt charging really means for the Tesla Semi, why it matters for the US trucking industry, and whether this technology is truly ready to scale when official Semi sales begin in 2026. Why 1.2 megawatts is a big deal. First, some perspective. The Tesla Semi isn't a regular electric car. It's a Class 8 long-haul truck with an estimated battery size between 800 and 900 kilowatt hours, roughly 10 times larger than the battery in a typical EV sedan. Years ago, Tesla claimed the Semi could recover 70% of its charge in about 30 minutes. Many industry experts doubted it. The math simply didn't work, until now. To push more than 600 kilowatt hours into a battery in half an hour, you need sustained megawatt-level power. Tesla has now shown that this is not theoretical. The hardware exists. The truck can do it. This wasn't a lab demo. This wasn't a computer simulation. This was a real truck pulling 1,200 kilowatts on American infrastructure. Why this matters more in the US than anywhere else? In China, megawatt-scale charging is already becoming common, even for some passenger EVs. The United States is different. Charging infrastructure here is fragmented, locally constrained, and often limited by aging grid equipment. Delivering 1.2 megawatts reliably requires coordination between grid transformers, power electronics, cooling systems, safety controls, and on-site energy storage. That's why this moment matters. Tesla didn't just build a truck, they built an entire charging ecosystem. The heat problem no one talks about. Megawatt charging introduces a brutal challenge: heat. At these power levels, even tiny electrical resistance produces massive thermal stress. Without advanced cooling, connectors would fail, cables would degrade, and safety margins would disappear. Tesla's solution includes liquid-cooled charging cables, immersion-cooled connectors, real-time temperature monitoring, and automatic shutdown systems. This is industrial-grade engineering. Consumer tricks that sometimes appear online, like trying to cool charging handles manually, aren't just ineffective here. At megawatt levels, they're dangerous. Battery longevity is the real question. Charging an 850 kilowatt-hour battery at 1.2 megawatts equals roughly a 1.4 C charge rate. That's aggressive, but not reckless. Tesla's confidence comes from its 4680 battery architecture, designed specifically for high current flow, improved cooling, and structural stability. This matters because semi-trucks aren't weekend vehicles. They're expected to operate every day for hundreds of thousands of miles. Megawatt charging must be repeatable, not just possible once. The grid reality and Tesla's workaround. Here's the uncomfortable truth. A single Tesla Semi charging at 1.2 megawatts draws as much power as a small neighborhood. Now imagine multiple trucks charging at the same time. Without buffering, local utilities would struggle. Tesla's answer is on-site energy storage, typically using large battery systems that smooth demand spikes and reduce peak load penalties. Without this strategy, electric trucking simply wouldn't make financial sense. Why the MCS standard matters. Early semi-prototypes used proprietary charging connectors. That was never going to scale. Tesla's move to the megawatt charging standard is one of the most important signals of maturity in this entire story. MCS enables cross-manufacturer compatibility, higher safety margins, industrial-grade locking mechanisms, and a shared charging future for electric trucks. For fleet operators, this reduces risk. For regulators, it improves safety. For the industry, it accelerates adoption. Charging time versus diesel reality. Yes, diesel trucks can refuel in about 15 minutes, but they also stop more often and require far more maintenance. Tesla designed the Semi around regulations, not hype. Range, around 500 miles, charging time, around 30 minutes, and federally mandated driver rest around 30 minutes. Electric trucking doesn't replace rest breaks, it uses them. The 2026 Semi refresh, built for reality. When Elon Musk said 2026 will be a banger, he wasn't talking about hype. The refreshed Tesla Semi Gen 2, spotted at Giga Nevada, shows a truck redesigned for real-world manufacturing. A new front light bar aligned with Tesla's broader design language, improved aerodynamics, simplified cab structure, anti-slip steps for driver safety, and updated camera placement for autonomy readiness. Efficiency has improved to around 1.7 kilowatt-hours per mile, roughly a 15% gain over earlier versions. That difference matters enormously in long-haul trucking economics. Why 4680 batteries changed the game. Early Semi-prototypes used LFP batteries, safe and durable, but heavy. Weight equals money in freight. By switching to 4680 high-energy cells, Tesla achieved the same 500-mile range, less battery mass, higher payload capacity, and lower production complexity. Tesla didn't chase extreme range numbers, they chased profitability and scale. Real-world validation. DHL recently tested the Tesla Semi over 3,000 miles, hauling full loads at 75,000 pounds. The results? 1.72 kilowatt-hours per mile, 390 miles per charge under load, 50 tons of CO2 saved per truck annually. Most importantly, DHL plans to expand its order. That's not marketing, that's validation. Final question for you. So here's the real question. Will repeated megawatt charging destroy batteries, or has Tesla finally solved the problem? If the 4680 technology holds up, the Tesla Semi could redefine long-haul trucking economics. If it doesn't, megawatt charging becomes an expensive headline. Share your opinion in the comments below. If you enjoyed this breakdown, subscribe to InfoByte Network for clear, no-hype analysis on EVs, technology, and the future of transportation. We've got another major Tesla update coming in just 2 days. Like the video, share it with someone in logistics or trucking, and turn on notifications so you never miss what's next. Thanks for watching InfoByte Network, and we'll see you in the next video.